Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in today's video we are diving into a very exciting and fundamental topic in image processing, filters. Now you might be wondering what exactly are filters in images. Imagine you have a photo on your phone. Sometimes you want to blur it, sharpen it or detect edges to identify shapes. Behind all these operations, there are small matrices called filters or kernels. So whether you are learning computer vision, robotics or just curious about image processing, this video is for you. So without further delay, let's jump right in. So let us understand what is a filter. So basically a filter also called a kernel or mask. It is a small matrix of numbers and that is used to transform an image. That means, suppose that if you have an original image, so you want to make that input image, that pixel should be sharp, so you can use a sharpen filter. So you want to modify an image, so you will require a filter. And what is the purpose? Like emphasize certain features like edges if you want, textures or smoothing details. So for these tasks filters are used. Now basically filters are applied to an image using convolution or correlation. Now during convolution the filter slides over the images or an image that computes a weighted sum of neighboring pixels to produce the output. We will see that. And filters are used to achieve different image processing effect. So not for only one purpose, for a many purpose filters are used. Smoothing or blurring, as I discussed. So like reduces noise, soften edges, sharpening enhances edges, fine details. Edge detection for a machine learning or deep learning. In deep learning, CNN automatically extract the features, but it requires a filter matrix. And basically these are the typical filters: 3x3, 5x5 and 7x7 you can use. And each element in the filter is called a weight and determines the influence of surrounding pixels. So value of the weight that will determines the influence of surrounding pixels. You see that what is the mathematics behind convolution. So if there is image I and filter k, so and see that these are the pixels, so you will multiply, this is the kernel, you will multiply I with each pixel ij, and thereafter you will get the weighted sum. So that is the filter and this is the image, and this is the basically convolution operation, and you will sum all. So I is image and are also called input image, k is filter, kernel or mask, xy that is the coordinates of the current output pixel, I is a coordinate inside the filter. So coordinate for current output pixel, and this one coordinate inside the filter. Step by step convolution. So place the filter at the top left corner. So it is telling that if you have an image and see that if there is a filter, so you will place here top left. If you have 3x3 filter, so you will place like this one. Thereafter it will slide. And multiply each filter value by the corresponding image pixel. Now sum the result to get a single output pixel. We will see that. Move the filter and repeat for all pixels. So filter will move. Now see that for the sake of simplicity, I have taken very small image patch, and image is basically 3x3 and also filter is of 3x3, and filter I have taken mean filter, that is the simplest one. So what will it do? It will just take the mean of all pixel values, and see that it is 3x3, so number of pixel would be 9. If you take k 4x4, so that would be divided by 1/16, not 1/9. Thereafter convolution, so here you can see that 1/9, and you will multiply 1 by 10, 20 by 1, 30 by 1, and thereafter you will divide all by 9. So the same image patch matrix is written here. So average pixel is 50. So it will average the pixels. It will take average of 9 pixel and it will just put into the output image. Here widely used filters, 3x3 filters are there. Now let us see another one like edge detection. That is Sobel X. So that is, suppose that this is the pixel. So it checks that whether intensity is being changed. If intensity is being changed, so that would be horizontal edge. So you can see that from here to here. Now vertical. So if intensity is changing, so that is the vertical edge, like this one. It is becoming from 1 to -1 or 2 to -2. So intensity is being changed. So there is an edge, that means. Sharpening. Let us understand some key points. Filter, a small matrix applied to an image. Convolution, sliding filter and computing weighted sum. And filter effects depends on weights. It may be smooth, sharpen, or for detecting edges or extracting features. We will see in the next video. And visual example help understand the transformation, and we will just use, see that here Python code. So just I have not used library. So import NumPy is NP, and this is the image patch. Thereafter 3x3 mean filter. So np dot once 3x3 matrix divide by 9. Now here center pixel np dot sum. This is the image and this is the filter, and this is the convolution operation. See what I am writing, or operation. So convolution operation, and thereafter it will print the center value, that was 50. So let us run it and see the value. Here I have already taken, and this is the first one. So let us run it. So average pixel value is 50. Now here next one, I am just taking real image and thereafter it is example.jpg, but I will change it for my own image. So you will see that here image I have taken brownwell.jpg because that is an leaf disease based, like paddy leaf disease image, and it is being changed into grayscale. See that I have taken filter 9x9, so I am dividing it by 81, and thereafter filtered operation would be applied, and thereafter we will see the result. So without further delay, let us see the result. You can see that is the original and this is the filtered one. So you have seen that how filtered is applied. Now for more videos and resources, you can visit www.postnetwork.co, YouTube channel, Facebook page, LinkedIn page and GitHub repositories. So hope you understood. Thanks for